Okay, so in the sake of time, let's go back to quadratics. Is your brain on quadratics? Are you able to warm it back up for quadratics? Yet another quadratic lesson. We're rolling through them. Eventually we'll get to the end of the unit, but we're on number 13. This one's called factoring trinomials. Just as a disclosure, we've factored trinomials before. But now I want to push you a little bit more and see if you can maybe do some of it on your own and or think through it and or see what your experience level is, etc. Okay, are you trying to give me attention up here? Try to stop what you're doing and try to direct up here, if at all possible. If at all possible. Are you with me? Okay, direct up here. Try to, let me get your attention. Please, please, and thank you. It's only going to be for a little bit. All right, ready for some questions? So warm up on quadratics. Why is it called a quadratic? It is produced by 4 multiplication steps. Okay with this? What is that acronym we use to describe the 4 multiplication steps? Everybody say FOIL. Remember? And that's your trigger for what those 4 are, right? And you're trying to do first, outside, inside, last. What are the 2 items we're multiplying together to produce a quadratic? What are those 2 items we multiply? We do the 4 multiplication steps on. What are those called? Binomials. Everybody say binomials. Can you picture it in your mind? Can you picture one in your mind? No? Okay, fair enough. So if I go like this, do you see the parentheses? I'm trying to do parentheses and parentheses. Does that help you at all? Yeah. Do you see what's in them now? Yeah. You can tell me what's in them. Give me an example of what could be in one. What could be in one of the sets of parentheses? And it's okay. If you can always say pass and I don't know yet. Okay, perfect, you guys. You can always say I don't know yet. Remember the power of the yet, right? That's fine. And remember, when you show up in the morning, your brain has flushed all kinds of things. You with me? It's a natural thing. It happens to all of us, and thank goodness. Otherwise, we'd remember every Facebook page we ever scrolled through, right? Which your brain is just protecting you. So warm back up on this. Here's what it looks like. It looks like this. Those are the 2 sets of parentheses. In each one, who wants to give me examples? Somebody remembers what could be in one. What could be in one? What could be in one? Make it up. We're making it up right now. We're making up a binomial. What does bi mean? Good. So I mean, use all your clues, right? You know, in English they teach you to use context clues, right? Use all that in math too. If it's called a binomial, get your brain going by. Okay, there's 2 in there, right? What's one of them? Good. One's an x, right? We're dealing with x and y graphs, right, on a Cartesian coordinate system. So your brain should be able to sort of try to trace back through. Consider yourself a detective, right? You're tracing back through all the evidence. You're going, what are we talking about? What is this, right? Can I remember? If you can make yourself remember it and build your own problems, your brain will be able to then, understand these topics better, right? And on some level, I always ask students, can we grow as humans without some sort of pain? Can we grow without pain? And I don't know the answer. I don't like the answer. The answer to me is no, it always takes pain, which I hate that answer because I don't like pain. Are you with me? So but I want to grow, right? I want to grow. I don't like pain. What am I going to do, right? I'm bouncing back and forth going, oh, okay, here we go again. Okay, this is painful. But I need growth, right? We need it as humans. Without it, we die. We wither and die, right? So, okay, so there's an X. I'm going to put the X's here in the lead position. Fair enough? Because that's the way we kind of always do it. And remember a pattern for yourself just to help yourself out. What else is in there? Minus what? 6. Fair enough. And we're just putting something in, right? Because we can always multiply it and it'll produce a trinomial. What do you want in this one? +3. Fair enough. And you just created 2 binomials being multiplied. They don't show it. It's multiplied between there. Now I can do the FOIL of first, outside, inside, last. First would be x times x is x squared. So I better draw that. Sometimes I have to draw the arrows to help myself out. Okay, first, outside, then inside, then last. I do that all the time. You should too. I've done way more of these problems than you and I still do it. It will help you to do it also. Okay, so x squared, so outside now. 3 times x is plus 3x Minus 6 times x is minus 6x. Minus 6 times positive 3 is a minus 18. Now I can combine like terms, CLT. Minus 6 plus 3 gives me a minus 3x. It's the negative's larger, right? Plus the other one. The x squared is still here, and the minus 18 is here. So we took two binomials, we completely made them up. Now when you see those, right, does your brain go back and go, okay, that's what it looks like? And I would, try to push yourself to go, let me remember that for next time, right? If you're willing and you're able. And again, it's all a work in progress, you guys. So it is what it is. And I like the group thing too, where one person says X, another person says minus 6. Everything starts to build in a group when you guys start to work in a group. And this is a group and your brains are keying off each other. It's the way we work, right? So here's the trinomial, 1, 2, 3. Now we're factoring, we're going backwards. Your goal is to go from this back to this, the one that produced it. Is it easier to walk forward or is it easier to walk backward? Forward's easier. So this is easier for our brain. This is multiplication, this is division. We're going backwards. We're going to try to factor all these. First, is anybody advanced enough to do it in your mind? Can you factor these in your mind already? Okay, fair enough, and I appreciate that. I found this very difficult as a student. I really did, and I don't know if I'm that great at math, but as a student, I found this extremely challenging. So for me, I had to go through certain steps. These are easier because there's no lead coefficient here. Remember our generic. Our generic is ax squared plus bx plus c, right? And we often put it equals 0 in here because we want to be able to solve for the roots. And so it has to be equal to 0 for that. So there's no a here. Well, I take that back. A is 1, right? Thank you. Yeah, you're going to tell me you're going to correct me in my own correction, right? A is 1 here. So that makes this factoring a lot easier for us. This is a lot easier than if there was a 2 out here, for example, because then we'd need a 1x and a 2x so that when you multiply them, it came up 2x squared, something like that, right? And that's what you're starting to do. You're going back through the 4 steps. Hey, I multiplied the first terms by each other, and that gave me this lead term. So if I'm going to reverse it, I need to know what 2 terms multiply by each other to equal that power 2. Does this make sense? So your brain starts to go, well, gotta be this. Gotta be. Now I need it to multiply. See how they multiplied to equal the tail. So negative 6 times positive 3 was negative 18. Part of me is asking, what are the factors of negative 18? What 2 things multiplied together to get negative 18? Are there other options for negative 18? Right here we had a 3 and a 6. What else could equal 18 if you multiplied it? 9 times 2? Bingo. Good. What else? 1 times 18 or 18 times 1? Yes. And they can start to reverse depending on the sign. The sign can really mess with us. Now it's a negative here, so I know one of these had to be negative, right? If one of them's negative, now I'm asking, well, when you added these, you came up with a negative 3x. So I know that whatever number was negative was larger because it produces this. You're forcing your brain to go reverse through all the steps, right? It's hard. This is harder. You're trying to now balance these different things. Well, what 2 numbers multiply to equal negative 27? A 9 times 3. Did you say one of them was negative? Because don't I need? You want the 9 negative? Okay, negative 9. But now let's add them. What is negative 9 plus 3? Equals negative 6. Is this middle term negative 6? So what can I reverse about what I started here? Because you took a shot at it, and it looks like we got close already. We could have gone through a lot to do 27. Well, no, I take that back. The only other one would be 1 times 27, right? There's not that many things that equal 27 when you multiply. Okay, not that many factors of 27. So we did pretty good already because at least we got the value 6. We have the wrong sign. What could you do to this to make this addition problem come out positive? Because it's got to come out positive. Make the 3 negative? So reverse this. I don't like that because it doesn't work. But if I had a positive 9 times a negative 3, that would still be negative 27, check. But when I added 9 minus 3, I would get a positive 6. So this is out, and I'm switching this. Now once I've got that, all I have to do is say positive 9 and negative 3, and I'm done. And you can reverse it, just like in all your equations, you can check it by going backwards. X times x is x squared. You know, last, negative 3 times positive 9 is a negative 27. A positive 9x minus 3x is a positive 6x when I combine like terms. And so it's your familiarity with the FOIL process, right? The first, outside, first, outside, inside, last, right? That whole process becomes essential for you to reverse it. In fact, you have to know it better to reverse it than you did to go forward. You have to get even better to do the reverse. Okay. On your paper or something, can you go straight to the answer on this one? You've seen the process. Some of your brains thought through it a little bit, or a lot. Can you do this one? By the way, what's that app on your phone you could be using, right? What's the app? I like this one, but you can do whatever. There's a bunch of them, right? I like Photo Math. And it looks, the icon for it is something like that. I'm not totally, and it's red. Because if you're at home trying to do these, you're gonna need some help. You need an answer to it, so to work backwards, right? You can't just be all alone doing these things. You're gonna need something. So the apps are really in your favor these days. What do you think? Do you know where to start? Are you trying it? Do you need to write some stuff down? Right? Will that help you? Because our brains work in little bits. If I can get one thing nailed down, then my brain's free to work on the next. My brain has very limited processing power. I can't think of the whole thing at once. I gotta think of this chunk, then that chunk, then that chunk, right? I need to go in order. What do you think? Do you know it? You do. Interesting. What did you just type in? Yeah. 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 Nice. Yeah, and you're using your calculators, fine. I do that too. Even when especially when I don't always remember all my calculators. Use your calculator, right? See if you can try it. Are you trying it? Are you pushing your brain to do it? If you're done with this one, you want to jump to that one? When you added those, what did you get? Okay, good. But what's the problem with that? So how do you make that happen? How can you make that happen? You're close. You're obviously close. You're right there on the edge of it, right? It's just that question of how do you change that sign? How can you change a sign? they wait on the announcements. And so I'm going to push you a little bit. What did you guys put in for the lead factors here and here?
-6 and -8.
Okay, so you're going straight for this. Because isn't negative times negative a positive? And then when you add them, doesn't that produce that? Right, does that make sense? Right, so you're right on the edge. You got to know all your different skills now got to come back into play, right? You got to know, and you got to know multiplication rules. Negative times negative is positive. And you got to know addition rules. Oh, I'm adding two negatives. That makes a bigger negative. You're switching between the rule sets for multiplication and division of negative numbers and addition and subtraction of negative numbers, right? You're kind of doing a lot of stuff at one time. You got to bring all that back in. Good? Okay, can you do this one quickly? But, well, what are your two factors?
9 and
9 and 5, right? 5 times 9 is 45. And is 5 plus 9 14? Good? But it has to be negative. So what do I have to do to both? Melanie?
They have to be negative.
Yeah, they got to be negative. Because that way negative times negative is a positive and negative plus negative is a greater negative. So this has got to be x minus 5, x minus 9. By the way, could you have written x minus 9 and x minus 5? Sure. Those are, remember, you can switch multiplication things. 3 times 5 is 15, and 5 times 3 is 15. That doesn't matter. They can switch in the multiplication realm, right? That's fine. That's back to the very beginning when you learned like the rules of multiplication. It was this whole idea of a rule set that you can switch them. You could do a times b equals c, and you can do b times a equals that same c, right? I think is the way we mapped it out. Okay, is this good? Is this enough for now? Because they're going to cut me off any second now.